You know the difference between knowing the name of something and actually understanding it? Say I show you a bird, a beautiful bird. In English, we call it a cardinal. In German, they call it cardinal. In Japanese, it's ashabini. Now, if I tell you all those names, all those different words, have you learned anything about the bird? No. You've only learned what different people call it. You still don't know why it has that color. You don't know how it builds its nest. You don't understand the bird. This is the fundamental problem with how we talk about technology. We know the names. We say artificial intelligence like we understand what it means. We say quantum computing like we've really thought about what that is. But have we? Let me be honest. Most of the time, I don't think we have. I think we're just using the names. So let me ask you a very simple question to start. What do you actually mean when you say artificial intelligence? Think about it. Not the definition you read somewhere. What do you actually mean by it? Because if you can't explain it in simple terms, if you have to hide behind big words and complicated explanations, then maybe you don't understand it as well as you think you do. And that's okay. That's not an insult. It just means we need to be more careful about how we talk about these things. Now, the reason I'm bringing this up is because we live in a world where we're constantly being told about breakthroughs. Something new arrives. We read about it. We get excited or excited and scared at the same time. And we think we understand it. But reality, now this is the important part. Reality doesn't care what we think. Reality just is. And when something actually has to work, really work, in the real world, reality takes over. It doesn't take any shortcuts. It doesn't care about public relations. Nature cannot be fooled. Let me give you an example from my own experience. I was involved in investigating the Challenger space shuttle disaster. Now, here's what happened. NASA's managers said the probability of catastrophic failure was 1 in 100,000. 1 in 100,000. Those were the numbers they used to recruit teachers into the program. But when we actually investigated and talked to the engineers who built the shuttle, they said the real probability was closer to 1 in 200. 1 in 200. So which was right? Well, the disaster answered that question rather definitively, didn't it? The difference between those two numbers, between 1 in 100,000 and 1 in 200, wasn't just a mathematical error. It was a failure of reality checking. It was people saying what they wanted to be true instead of what was actually true. So now, let's play this game. Let's actually imagine that tomorrow, all these new technologies we hear about just appeared fully functional. Let's test them against reality. And I want you to really think about what I'm saying, not just accept it. Okay, start with artificial intelligence. Everyone's talking about it. ChatGPT, machine learning, neural networks, all of it. Now, what is it really? If I cut through all the jargon, what we have is a system that can recognize patterns and data. It's very good at it. It's remarkable, actually. You give it a bunch of examples, and it learns to do something similar. It's like showing someone thousands of pictures of cats and then asking them to draw a cat. After seeing enough examples, they'll be pretty good at it. That's essentially what's happening, though of course the mechanisms are far more complex. But here's the question. Is that intelligence? Really, truly intelligence? See, intelligence to me means you can understand something new that you've never seen before. It means you can apply knowledge in unexpected ways. It means you can know when you don't know something. When you meet a situation you've genuinely never encountered, can you figure it out from first principles? Can you admit uncertainty? Can you ask good questions? Now, modern AI systems, they don't really do that. They're pattern matching at a very, very high level. They're remarkable at it. They can do things that are genuinely impressive. But if you give them a problem that's sufficiently different from anything they've been trained on, they don't know what to do. They don't even know they don't know. They'll confidently give you an answer that's completely wrong. We call this hallucinating, which I think is a funny way to describe it. The system is doing exactly what it was designed to do, produce plausible sounding text. It doesn't understand. It doesn't know whether what it's saying is true. It just knows what usually follows what. So tomorrow, if artificial intelligence arrived in full form, what would that mean? Well, think about what would break. Every job that's basically about pattern recognition, analyzing X-rays, reading legal documents, writing boilerplate code, those would probably be fine. Probably better than fine, actually. But what about jobs that require judgment? What about situations where you need to understand the context? What about the things that require actual knowing? And here's what troubles me more. What about truth? See, we've always had a problem where people lie. People deliberately deceive. But at least there was an implicit understanding that there was a truth being lied about. Now we're creating systems that can generate thousands of plausible-sounding lies automatically. They're not lying deliberately. The system doesn't know it's lying. But the result is the same. The world gets filled with stuff that sounds right, but isn't necessarily true. And if people can't tell the difference, if they just accept it because it sounds good and it came from a computer, well, what happens then? That's the reality check. Not whether the technology works technically. It works. The question is, what happens in a world where we have this tool, but we haven't thought carefully about what it means? Now let me talk about another one. Quantum computers. Everyone's very excited about quantum computers. They're going to be millions of times faster. They're going to solve problems we can never solve now. Maybe. But let me ask you, why are they faster? What does it mean for a quantum computer to work differently from a regular computer? It has something to do with something called superposition. In regular computers, a bit is either 0 or 1, on or off. But in quantum mechanics, something can be in multiple states at once, until you measure it. Then it becomes one or the other. This is called superposition, and if you think about it very carefully, it's a pretty weird idea. In fact, quantum mechanics is weird. It's so weird that even physicists are not entirely sure what it means. We use it. It works. We can make predictions. But what it means, what's actually happening, that's philosophically murky. But the point is, quantum computers can theoretically try many solutions to a problem simultaneously using this superposition property. That's the idea. The reality? Well, several things. First, quantum states are incredibly fragile. The slightest disturbance, heat, vibration, electromagnetic radiation, and the system collapses. The information disappears. So you need to keep quantum computers at temperatures colder than outer space. You need to isolate them almost perfectly. That's hard. That's expensive. And second, the problems we can actually solve with quantum computers are much more limited than people think. It's not like you can just take any problem and solve it faster quantum computerly. No, you need a specific type of problem with a specific structure that quantum computers are good at. So if quantum computers arrive tomorrow in full, usable form, what would actually happen? Well, certain types of problems would get solved faster. Cryptography might be affected. That's a real concern. Drug discovery could potentially be accelerated. But most of the everyday things we use computers for, email, word processing, video games, those don't benefit from quantum computing. Those don't have the structure that makes quantum computers useful. So the reality is a bit less revolutionary than the hype. This is what I mean by checking against reality. You have to ask, how does this actually function? What are its real constraints? Where does it actually help, and where is it being oversold? Let me talk about something else that people get very excited about. Fusion energy. Unlimited clean energy. The stars do it. Why can't we? Well, here's the thing. Yes, the stars do fusion. They're giant nuclear reactors in the sky. But here's what people don't always realize. It takes a star. The sun has about 300,000 times the mass of Earth. That enormous gravity holds the hydrogen together under pressures we can barely imagine. And even then, fusion only really happens in the core. We've been trying to do fusion down here on Earth for 70 years, and we can't quite make it work. We can make fusion happen. That's easy. You just explode a nuclear bomb. Boom, fusion. But making it happen in a controlled, sustained way that produces more energy than we put in, that's the hard part. In fact, for decades, we've been saying fusion power is just 20 years away. 20 years. I've heard this my whole career. You know what the fusion people tell me now? They say we're about 20 years away. Still, so if fusion energy arrived tomorrow, if we suddenly had reliable, scalable fusion power plants, what would that mean? It would be transformative. Electricity everywhere, cheap. The energy equation of civilization would change. That's real. But here's the catch. It's not just about the energy. If you want to power the world with fusion, you need to actually build these plants. Thousands of them. You need workers to build them, engineers to design them, infrastructure to distribute the power. You need the economic system to support it. And we don't exactly live in a society that makes decisions based on pure logic. There are interests. There's money. There's politics. This is what I find so interesting. People focus on the technical problem, but they don't think about the human problem. Even if we solved fusion tomorrow, how fast could we actually implement it? Who decides where the plants go? Who makes the money? What happens to all the people who work in coal and oil? Does the society just smoothly transition? I don't think so. Reality is messier than that. Here's what I really want you to understand. There's a difference between a technology existing and a technology being deployed and actually working in the real world with all of human behavior and economics and politics involved. These are often treated as the same thing, but they're not. Not even close. Let me give you another thought experiment. Nanotechnology. You can arrange atoms the way you want. You can build anything at the molecular level. That's the promise. And you know what? The physics isn't wrong. In principle, it's true. But here's what people don't think about. If you can build anything at the molecular level, you can also build anything bad. You could build a weapon. In fact, you could build tiny robots that reproduce themselves and disassemble everything. You could destroy the world with nanotechnology. Could you? Well, yes, maybe. Theoretically. But would you? Would anyone knowingly? I hope not. But the point is, we're now talking about risks that might not be purely technical. They're philosophical. They're about human nature. And here's something else I want you to notice. As technologies get more powerful, as we get more control over matter and energy and information, we also get more ways that they can go wrong. The stakes get higher. A mistake with a hammer affects maybe you. A mistake with a nuclear power plant affects a city. A mistake with nanotechnology that reproduces and spreads, that could affect everything. This is why I'm not actually a technologist in the usual sense, even though I work in physics. I'm interested in how things work, yes, but I'm also deeply interested in how we think about how things work, because that shapes how we use them. Let me tell you something about how I approach learning and understanding. I have a method. Some people call it the Feynman technique now, which is funny to me because I wasn't trying to make a technique. I was just trying to understand things. But the idea is simple. If you want to understand something, explain it as if you're teaching it to a child. Not a brilliant child, a regular child. Use simple language. No fancy words. And when you can't explain something, that's where the gap in understanding is. That's where you need to do more work. If we applied that to all the technology hype we hear, I wonder what would happen. Someone says, artificial intelligence is transforming society. Okay, explain that to a child. What does that mean? The AI can write essays? Well, yes, it can, but it's copying patterns from what humans wrote. Is that transforming society? I don't know. What does transforming mean exactly? Are people's lives better? Are they happier? Do they understand things better? These are real questions. And I noticed that when people try to explain the impact of technology in simple terms, it becomes a lot harder to make sweeping claims. You know, I think there's a difference between being pessimistic and being realistic. I'm not pessimistic about technology. Technology is amazing. We've done extraordinary things. But I'm skeptical of hype. I'm skeptical of claims that aren't clearly thought through. And I'm especially skeptical when I see people talking with certainty about things that are genuinely uncertain. Let me talk about what I think is the deepest issue here. In science, we have a method. You make an observation. You propose an explanation. You test it. You see if the explanation matches reality. If it does, great, you might have something. If it doesn't, you change the explanation. Or you reject it. This process works because reality is the referee. Reality doesn't care what we want to be true. It just is what it is. But with technology, especially with future technology, we don't have reality as the referee. We have hopes, fears, speculations. We have marketing. We have people trying to get funding. So the process breaks down. Someone claims something will work, and because there's no immediate way to test it, it just hangs there in the realm of claims. And if enough people say it, it starts feeling true. This actually happened with some of the claims about the space shuttle reliability. Because no one was asking the hard questions consistently, NASA managers believed the numbers they were given. They weren't intentionally lying. They just weren't checking against reality. Or maybe they were in an environment where checking too hard against reality made you unpopular. I don't know. But the point is, the breakdown of reality checking was the real problem. So here's what I want you to think about. When you hear about a new technology tomorrow, here are the questions to ask. First, explain it to me simply. If you can't do that, you probably don't understand it. Second, what's the evidence that it actually works? Not in theory, in practice. Third, what are the constraints? What's hard about it? Every technology has hard parts. If someone tells you there aren't hard parts, they're not being honest. Fourth, if this works, what actually changes? Not the hype version, the real version. What's different? And fifth, who makes decisions about how it's used? Because that matters as much as the technology itself. I don't care whether we get fusion energy or quantum computers or artificial intelligence that's smarter than humans. Those are all interesting questions. But I care a lot more that we think clearly about these things, that we don't fool ourselves. Because the first principle is that you must not fool yourself, and you are the easiest person to fool. So if all these technologies arrive tomorrow, all of them, fully functional, my first question wouldn't be, how do they work? My first question would be, do we understand what they actually mean? And do we understand what we're going to do with them? Because having the power to do something and understanding what we should do with that power, these are not the same thing. Now, I notice people often get frustrated when I talk this way. They want me to be more optimistic. They want me to celebrate technological progress. And I do celebrate it. I think what humans have accomplished is genuinely impressive. We've figured out so much about how the world works. We've built things that would seem like magic to someone from 100 years ago. That's wonderful. But that same technological power can also destroy us if we're not careful. It can fool us. It can make us overconfident. There's a balance. You should use new knowledge to do good things. You should be excited about possibilities. But you should also have a healthy skepticism. You should ask hard questions. You should be willing to say, I don't understand that, and mean it. You should test claims against reality, not against what you hope is true. Let me come back to where I started. What if all these amazing technologies arrive tomorrow? My answer is, it would depend entirely on whether we had also developed the wisdom to use them well. And I'm not sure wisdom scales the same way technology does. I'm not sure you can have an exponential increase in power without a corresponding increase in understanding and care. That's not pessimism. That's just honest assessment. We have to check against reality. Here's something that kept me going through my career, something that still seems true to me. The world is genuinely interesting. More interesting than any single discipline, any single belief system, any single explanation. There's always something else to learn. There's always another layer to things. And if we approach technology with that same sense of curiosity, really trying to understand, not just accept, not just get excited, then we're in better shape. So I guess what I'm really saying is this. Tomorrow, if the technologies arrived, the most important technology we'd need wouldn't be the new one. It would be the oldest one we have. It would be the human capacity to think clearly, to question, to check against reality, to admit uncertainty, to be curious about what's actually true, not just what we want to be true. That's the real breakthrough technology. Everything else follows from that. The name of something is not the thing itself. Don't fool yourself. Check against reality. Stay curious. Keep asking why.